Hello everybody! Welcome to Techniques for Maintainable Quarkus Applications. I'm happy to be here today with you. I'm Anna, I'm a Java champion and working as an architect in my day-to-day life. I also like to share my experiences and experiments, different conferences, or within the Bucharest Software Craftsmanship community, which I co-founded together with my dear friend Victor Renta. In today's talk, I will showcase a few techniques to write maintainable code that can help you to write maintainable code. The reason being, software that is maintainable can reduce not only a system's lifecycle cost, like is written in the slide, but also can help and enhance the way your productivity is going on in your day-to-day life as a developer. What I'm speaking about here is that maintainable software it means mainly that you are easily repairing something, you're fixing something, but not only this, you're also evolving what you have written or what others have written in a very easy manner. You do not have to rewrite everything. You are not afraid of writing code in a specific part of your application. So this is pretty much what maintainability is. And since we have just started the conversation about maintainability, one architecture that supports writing highly maintainable software systems and is nowadays very much loved is the microservices architecture. The reason being that this type of distributed architecture allows you to work in an isolated mode at mini applications that can be orchestrated in order to do what your end users expect as functionalities from the system you're building. And what I'm talking here is that probably some of you already have worked with microservices and experienced that you can develop in isolation, that you do not care very much about or wait for dependency within other applications to be ready in order to create your own and do development on your own application, to fix your own application, and of course to deploy it. So this kind of architecture that allows you to do your work regardless of what's going on around you and focus on that is a very good stimulant for you to write more maintainable code. And since we introduced microservices, of course, when you're writing microservices, you can choose different languages. But when you are looking to write microservices with Java, you have several options, Quarkus being one of them. Quarkus is an open source Kubernetes native Java framework that is tailored for GraalVM and OpenJDK hotspot. It has a few things that have drawn me as a developer, and I pretty much like the experience I had so far with Quarkus, because besides the unified configuration that many other frameworks can come with, I really like the fact that I have live reload, so I don't need to depend on a certain IDE to write code and have this nice live reload with Quarkus. Secondly, what I liked about Quarkus is that when working with persistence units, like working with a database and I'm having JPA or Hibernate with that database, I pretty much have had Panache to help me writing and abstracting a few parts of the code for me. So Panache is coming on top of JPA and Hibernate to make repositories and to help me working with these two in need. And last but not least, as I'm also coming from the Spring world, I've worked with Spring MVC, I've worked with Spring Boot. Well, Quarkus has Spring API compatibility. So if you're used with Spring and you want to easily lean into and go into learning Quarkus, you can do it and you can combine both by using the Spring API compatibility. And what Quarkus brings to this union is the fact that you benefit of early detection of dependency injection errors at compile time and not at runtime when you're using both of them. So I hope that I'm giving you a few reasons why to use Quarkus. You can ask many more reasons in the chat, or you can share your reasons in the chat why you like Quarkus or why you would be interested to work with Quarkus. In moving forward, in our incursion today, we are going to look at, of course, writing more maintainable code for an application. And the application that we're gonna stick together today is called Stitching Facts. So the Stitching Facts is a Quarkus application, and we want to write more maintainable code and to enhance a few things around Stitching Facts. What Stitching Facts is, of course, is exposing an API for consuming. I put here some folks and some end users, but you can think of like Stitching Facts correlated to some other applications as well. And the facts that are being stitched within it are being consumed from a cat facts API that's maintained separately from my system. It's not under my control. And I'm just consuming some information from there that I need to manipulate a little bit more for my end users to receive them and to read them, or for other applications to consume. And sometimes when I'm interacting with this cat facts API, I want to keep a few things from it. And I've used the Stitchy, the PostgreSQL database, to keep the things that I'm interested in to keep from the cat facts API in my own persistence unit, so that I don't go every time to the cat facts API and just do some round trips that kind of cost me in duration of the requests. And those being said, let's go to the IDE and do some coding. Before spending a lot of time here, just gonna give you a brief overview that when working with Quarkus, you can start working with Quarkus and generate your own Quarkus application at code.quarkus.io. And you can choose whatever extensions you like. So today my application has some code that was generated with these extensions, and we're going to enhance on it. So because as the name of my talk is, we're writing maintainable applications, and the expectation is that something is already written there. So let's go a little bit to the IDE. Now, the Stitching Facts app, it has a few details that I want to bring to your attention. So first of all, like any Quarkus app that you're going to generate with some boilerplate code, it has a generated endpoint, but in my case, I have refactored it a bit. It's called facts endpoint, and it's going to be the one that's going to expose my created API to the end users or to other applications for consumptions. It has application.properties where the unified configuration is staying on for how, and I'm keeping some configs for my app, and of course some tests. So there are some tests that come by default when you're generating your Quarkus code, but you can also make your own tests based on that. So we have some already written code with Quarkus, and the first place we're going to stop is the application.properties. As you can see here in application.properties, there are some global details that I established for my app. So one of these global details, besides the console log format, so how I'm going to log my output to the console, like here, is the fact that I have also defined the cat facts API that I'm going to consume. So what I'm expecting here and what is going on here is that I have defined that my cat facts API that is available at this URL is going to be consumed from this URL, but is connected inside my application code, my Java code, as a REST client to the fact service interface. So I've connected with this single line the fact that I'm consuming from this URL in my own application via the fact service interface. And the fact service interface is the one here. I just registered it as a REST client, and pretty much when I'm consuming this service, I am just using and injecting this interface in my code. So nothing more, no more troubles, and of course there is some elegance in this approach because I don't have to define another variable for the URL or anything else. The mapping between the two is happening in the application.properties. And looking a little bit down, I'm working in my local right now. So I have connected a localhost PostgreSQL database, which is running, of course, on 5432, my Stitchy local database. I have some script, and I'm pretty much interested in working on local. Now, if I'm keeping this kind of information, what this means is that I'm always going to see a lot of logs. So whenever my application is going to run somewhere else, not only on local, I'm going to get a lot of logs. And a lot of log information is not useful to everybody in a project. So you're probably working in a team, and you know that if you get too much info coming from your one application, not to mention if you're working in a microservices environment and you are kind of keeping an eye on many more, is kind of annoying. And also from DevOps point of view, you kind of get too much information from your app. And what you can do is that you can calm the noisy loggers with a few things. First of all, the Quarkus local I've set it like the global one to finest, which is a good idea if you really want to get a lot of information. But typically, you're not interested to get so many information. So for example, this one on finest, it says query executor implementation, BA parse complete null. These kind of information do not help me that much. So I'm pretty much going to change this one to info. And furthermore, I'm interested to, see how my app is behaving. But my app, I'm interested to know a little more. So info is not going to help me most of the time. And I would advise you not to not to log on info or an error unless there is something that would benefit to be there in your log files. I would advise to use debug most of the time when you want to put some places that can give you information about what's going on with your app. And if you're working on your local, you can also use trace, but please be aware that a colleague that might use this kind of configuration might be bothered when going further. And yeah, this is for calming the noisy loggers, but I don't want to calm the noisy loggers global. So if I want to have some differences in the profiles of my app, I can use the profile dev for my local and just tailor this configuration to be happening only for dev so that I'm not, disturbing the production mode of the app. So whenever somebody is getting this on their local, they're going to experience the same goodies that I've experienced earlier. Let me remove this guy here because I'm not interested to see much information. Now, when you're looking to production has a similar, let me just move this a little bit lower. Production has a similar view as dev, with the difference that I'm introducing some variables here because I don't know the username and the password for production database, and I shouldn't care about it. And for my logs, one thing that I did was actually to introduce some variables for it as well. The reason being, it's much more easier for you to control the log level from the pipeline, from the environment, and expect for that information to come from the environment and not being, hard-coded in your app, than actually hard-coding a value for an app. However, if you're worried that this might not be defined at the level of your pipeline, it can happen, and you don't want to break things. A good practice is to define a default value. So this is why you have this here. This info is given as default value. So I put them on default. And looking at the test part, well, test is pretty much similar with the other ones, but when I'm testing, I wouldn't like to use a PostgreSQL database because that would introduce a dependency. Like always, you need to have a PostgreSQL database somewhere available. And that is a little bit, resource consuming and is also troubling you, like, hey, if the database is changing, its host name, it's changing its user. So it's introducing a dependency that you shouldn't be worried about when you're building an application. What I did here, I'm using an in-memory database. And this is pretty much why I have created different SQL load scripts, because for my application, I had to define primary key generation differently, since in-memory database has a different way of handling primary keys from PostgreSQL database. And pretty much the rest is the same, and I'm just using information that are very useful for testing purposes. That's pretty much with the application properties and how you can tailor using profiles and using log categories, the noisy loggers. Let's move to our next step, to our app. So in our application, when you are writing endpoints for consumption, one thing that you are thinking about as a developer, when you're creating microservices, should it be asynchronous or synchronous? So in order to help you decide and have a good decision around that, what should be synchronous or asynchronous, what I've done here, I've created a synchronous version of an endpoint and the asynchronous one for the same endpoint. So they consume the same fact service, so the same fact service endpoint, the one from the CatFacts API. But the difference is that one serves asynchronous and the other one serves asynchronous. And I want to assess how these two are going, so which one is better and which one to keep. And I'm going to compare their response times. And my bold assumption is that synchronous time is 3 times bigger than the asynchronous one. So let's do some tests around that. So first of all, I need to establish a few things, like creating something that would help me to measure the times. And I'm using a micrometer timer that will measure the synchronous requests. And then I'll go with a micrometer timer for the asynchronous request. I'm just changing a few things here. And I'm going to say when So when do some 5 requests to the synchronous endpoint, measure that, and I'm going to do the same thing for my asynchronous requests and measure that. It's pretty much that, and just run the unit test now. Now, while this is running in the background and the expectation is that synchronous time is going to be bigger than the asynchronous one, we're going to move to the next part of this session, looking about how you could improve what's going on with your application with caching. So when working and consuming the fact service endpoint for in here, one endpoint, the fact ID one, I thought that it would be better if I'm caching the facts by ID. So what I did, and by the way, in the meantime, the compare response times has executed, and of course synchronous time is bigger than the asynchronous one. What I did here, I annotated with cache result my method. So I'm caching the results of the cat fact by ID asynchronously using the cache key for fact ID. So I'm using this cache to, like, not all the time when my users are asking information about related to fact IDs at certain endpoints. So for example, I have information about fact IDs here, at this one, here, as asking information about my fact IDs and randomness. I'm not all the time, reaching the endpoint. I'm just probably needing to query the cache if something is really cached there. And I define my cache. Now, any good cache definition, it also requires some more information like initial size capacity. So for example, for this one, I defined initial size capacity of 10. Let me just change the name because this is not the right name for the cache. It's animal fact async. And the maximum size of 20 and the expire after write. So the time that the cache is going to expire to 60 seconds. Now, one thing that you should be aware of when using cache is like they're not fully used, or they are not full, or that you're introducing some memory leaks with your cache. So let's test the performance of our cache by using a gauge. So another micrometer measurement gauge to see how our cache is behaving. And we're going to assess the cache size. I'm going to first retrieve the cache and define the gauge with its details, and then I am going to execute some tests. So I'm going to use 5 requests to be executed against the facts endpoint and see how the cache is behaving from fact service. And I have here I need to measure how many cache facts I'm expecting, regardless that these are 5-time invocations, by the way. So I have 1 fact ID. This is the same fact ID here. 2 facts IDs, 3 facts IDs. So my expectation is that when I'm measuring this is that I'm going to have 3 facts that are going to be measured by my gauge. So let's run the unit test again and see how this is behaving for the cache. This is one good approach when measuring caches. Another approach that I want to showcase to you is like looking how the distribution of events and how your endpoints are behaving, especially when you are having like intensive load of work and intensive work with them, and you're working with a lot of data. So speaking of a lot of data, when you're working with a lot of amount of data, or you want to work with things that are in preparation, or you're expecting a few things to be defined in preparation, I prefer to use GraphQL. So pretty much I like GraphQL for orchestration between the microservices, because you can define schemas and you can work with those schemas, and you can define a lot more easier integration points between yourselves and maybe some front-end applications. And there are many more benefits of GraphQL that I like, and you can ask me in the chat, by the way, about them. So I define my API, my facts endpoint API, as a GraphQL API, and this is why you see query above all these. Now, looking at this API, I just want to make sure that this API is working properly when it's working with fact service API. So what I did was actually, I wanted to assess a few things regarding my integration with fact service API. So I want to see how the distribution of events is going on when I'm working with fact service and integration. So I'm assessing a little bit the fact service, and it's good sometimes to do this kind of assessments when you're consuming a third party, because you kind of can see what is not behaving as expecting, and you can avoid some unexpected situations or some downtimes. So I'm going to say, given the metric registry, I'm going to register distribution summary for these. I'm gonna, see the distribution of events against this, the fact side, the invocation of get by type async from fact service, and then I am going to record 100 times this size. So I'm going to simulate like, okay, there are going to be 100 time invocations, but the response is going to be size all the time, and I'm going to record also an outlier size for this one. So this is going to be like a random number chosen from there. And my expectation is that I have 101 invocations, like 100 plus 1. And the distribution summary, the total amount of the distribution of events is this 100 on this size plus 1 or the outlier size. And I'm just going to run this one and see if these measurements were captured correctly. Another measurement you can do is you can use the percentiles to measure how things are behaving with your app, and you can have some percentiles and see how your app is behaving to certain points. Now, this test is similar to the one above. The difference is that I'm using the distribution summary with percentiles and a Prometheus registry. I am measuring the percent, what's going on here. Same with an outlier size. So I'm recording 100 facts with the same size and an outlier size. But I have also want to assess how it's going on with the percentiles. So my expectation in this case, is that the result is containing the 99% percentile, the outlier size. And I can do that by taking a snapshot, obtaining the percentile values, and mapping them and inspecting them for later and for better view. Besides measuring and tailoring the endpoint's response time with these kind of metrics, another thing that I want to bring to your attention is that sometimes when you're working within your application, you realize that at the beginning of your app, you want to make sure that you are preparing something in your database, or you are prepending something before everything starts and works. And one thing you can do this, it can define a class that's annotated with that startup that actually is going to do some work before the other things in your app are going to be invoked. So it's like prepare some data, and this is what I'm doing here as well. So I prepared some data, I'm getting some facts, initial capacity to some value, and I'm storing that in my database. And let me inject this two missing services here. So first of all, I'm just going to inject, enhanced. Okay, and let me just get the name from here. And I'm just going to copy paste fact service, and do this. Now, if I'm going to look into my application.properties, the initial capacity varies. So this is for dev is 100. For period capacity is 500. That takes a lot of time. Now think about tests. On tests, I don't need that much capacity. And one approach is like you set the initial capacity to 10. So it doesn't execute like when you're loading the entire context, you don't execute them like so many times. But another approach, if you don't want this to be executed with certain profiles, is to use if build profile annotation. So if build profile is different from test, this is not going to be taken into account. Well, let's go back to the presentation and do some summary of what we talked today. So some takeaways is that you can refine your log details per application profile and per package need. You can validate performance of your endpoints, and you can see the capacity of your caches using timer, gauge, or you can control your endpoint response time with distribution summaries and histograms. If you want to inhibit, execution of certain long-running endpoints that are not needed in certain application profiles, you can use if build profile. And this is a personal choice. You can listen to it or just ignore it. You can generate a GraphQL schema for each of your microservices and use that schema as teaching for further client consumption. Thank you very much for listening to me. The code is made available at my GitHub account, and try to go and see that one and get the code from there. And I'm expecting your questions in the chat, of course, and hopefully we're going to have a pleasant conversation during the entire conference. Thank you. See you soon.
Hi, Anna. How are you?
Hi. I'm fine. I'm fine. Well, I like to say that there are a lot of questions in the chat. The first one that I want to answer is, yes, the project is available on GitHub. It's shared at the end of the presentation. And I'm sure the organizers will share all the contents here. There's also Slack that I joined, so there will be shared. So there's no problem in not sharing the contents. I'm happy to be here with you and looking forward to answer the questions from the chat and your questions, Michelle, and many more questions that come.
Well, yes. Let's wait for the question. But yes, one of it was like, are you going to share the code? Because it's so concise. I love that when you were explaining and everything was very clear. And that's something I also like about Quarkus. It allows a lot of functionality in a very small space. So I think it's really nice for applications. So
yeah, so I really like Quarkus as well for many reasons. And I'm happy to see that is evolving. And when you answered to the question regarding what's available there in terms of working with databases, like templates for working with databases, with caches, with messaging, there are a lot of extensions available there. And actually, the way I'm looking at, I'm like keeping an eye on the code.quarkus.io. And afterwards, I'm searching for the guide that is available. Like I'm thinking, like maybe the extension is there. But afterwards, I'm just searching for the guide. Like, yeah, and let's just see maybe there's there, and it can help me. I pretty much like recently actually tried, because there was a need for that. Was Lickybase, the Lickybase extension. So for those of you that are looking for a way to evolve your data model, and you're still working with a relational database, and you want to evolve gradually your database, but of course production you cannot drop and create all the time. What can I say? Even the schemas from production, you cannot drop and create them every time. You can work incrementally with Lickybase. I personally prefer Lickybase. I know that a lot of people are into Flyway, but I prefer Lickybase because I used it many years ago in a Spring Boot project. I used the Lickybase micro plugin for generating stuff, and afterwards incrementing the changes and so on and so forth. But Quarkus has such an extension for working with Lickybase, and is pretty cool if you need to add incremental changes to your data model. I know that, there were some questions, not in the session, but that received during time, like, hey, some of the extensions are experimental. Aren't you afraid of that? I'm not necessarily afraid about experiments. I pretty much am ready to, evolve with these, and we are engineers. We're there to make things work. So, and the answer to like, hey, they're an experimental, do not worry. I can say from my own experience that I'm using the GraphQL generator plugin, so that generates a schema for your GraphQL schema. That is working. The thing is that the schema that it generates is good, but it would require a few tweaks. That's something that I've found over the time. I mean, it's a good schema, but you need to adjust it a little bit more manually. But at least from my point of view, as a lazy developer that likes to have things generated and sometimes boilerplated, is a good starting point than writing the schema by hand all by myself. Yeah. So that's it. And I'm just looking to the chat. Any tips to use Quarkus with Maven or Gradle? Well, I'm using, by the way, another tip for working with Maven, because I'm Maven most of the time. I'm not Gradle. And I know that for Gradle, there is an extension to working. I mean, you can generate your code, by the way, with Gradle as well. I think that's also experimental or something, and there are a few options working with it. But as tips for working with Maven, I'm always adding the extensions, like in the guides, with add the extension that you need with the command itself. I don't remember it by heart. It's easier and cleaner, by the way, than copy pasting things from the Maven repository. But of course, you might find that you need libraries, like Lombok, for example. Lombok, you're not adding from any extension of Quarkus that you would add by hand. I know there's a lot of concern, and there's also some concern when you are, growing, like not to have things that you forgot in your libraries. Yes, and there's a question, like, have you ever used, sorry for putting the questions. I'm not hearing you.
Can you hear me, Ana Maria?
Yeah.
Ichel says if you can follow up with the question about gRPC.
Okay. So I'll be the moderator and the speaker as well. That's great. Okay, so regarding the question about the gRPC instead of REST for the communication between services, if yes, what made you decide to use it? I cannot. So if I were to choose gRPC, I did have my own benchmarks regarding that one for certain cases, but REST is widely used, and most of the teams and team members accept REST better than working with gRPC. There are a few disadvantages to gRPC as well, and besides the all good known advantages, I mean, there is a situation with the content types. I mean, for example, like image upload support, if you need it, is not there. But most of the time is about people, because people like tools or things that are widely adopted, that have a lot of developer tooling, that you have a lot of ideas about common practices on how to handle the errors in all these things. So those being said, a gRPC is good if your team is also ready to accept it and embrace it. And from what I've read and I've seen, like people that are using it on GK, on Google's offering, are having some nice monitoring and infrastructure support there as well. But besides that, it depends on you and your team. Most of the time, I'm taking decisions all together with the folks that I'm working with. So it's not just me. Like, also with Quarkus, by the way, is most of common decision. Like we all like it, and we will all agree with it and learn to develop with it. It's not something that I personally can take a decision for others. Now, next for questions. I hope I am not missing these questions here. Did you use the specific Quarkus extension for Spring-like annotations? You mean like to work with AutoWire and all the Spring annotations? When we had to do some translations, translations from Spring to Quarkus, I do remember we used something. Because most of the people, let's face it, are acquainted with Spring Boot, and even myself, I'm coming from the Spring Boot world. So one reason of going with Quarkus was more like we could combine best of the two worlds. Like if it doesn't work with Quarkus, we can always do it with Spring and what's available in Spring. But most of Quarkus is becoming very more mature, I would say. And so I don't feel the need anymore of like thinking on how that would work with Spring. I do know a few things, and I'm also keeping an eye on the Spring ecosystem as well. And for example, there are a few things that, at least for Micrometer, are available with the Spring ecosystem, but I do imagine why that is more evolved for Spring especially. That I would like to see also with Quarkus, but I'm hoping that that will evolve as well. And yeah, there are a few more things that I'm actually looking into seeing evolve with Quarkus. But I think that it, it caught up pretty well in terms of development. And by the way, another thing that I want to share with you is like, if you're thinking of using Quarkus, try to POC first and, like have a good base on what you plan to do with it, not just go big because somebody said it's cool. Most probably you cannot convince people to go something because it's cool. It doesn't work for me, or I don't know for who it works, but for me, most of the time, it doesn't work when I say this is cool. So you need to have some measurements and see how that works. And of course, have the buy-in of everybody that they like this approach, that they would support this approach, and that, of course, they're ready to learn this. But the learning curve is quite easy. That's another thing that is surprisingly nice and good about Quarkus. It's not that difficult to learn. I've also experienced a long time ago some Java EE applications, some ER applications. And I do remember that after being with Spring and going fully Java EE, it was a shock. Let's just put it like this. It was a shock. And I was like, this used to be done with this. Now I have to recreate this annotation.
Yes, true. Well, we will have the Hangout with you still. For those who want to see the chat, it's there, the link, and also you can check the sponsor areas. Anna, thank you very much. I'm sorry for all my issues with the connection and the microphone and everything. Thank you very much. Your presentation was really good. And I also, as a user of Quarkus, I recommended it. The guides are really good. And thank you very much for your time, Anna. Thank you.
Thank you. Thank you, everybody. And looking forward to speaking with you on the Hangout. Moving there. Bye.